Hello friends. Today topic is Pavement Condition Index, that is PCI for concrete pavements. PCI for asphalt pavements has already been covered in my another video. Here two documents are for reference. One is ASTM D6433-07 and another is IRC SP83 2018, which is on maintenance, repair and rehabilitation of cement concrete pavements. PCI is a numerical rating of the pavement condition that ranges from 0 to 100, with 0 being the worst possible condition and 100 being the best possible condition. The Pavement Condition Index is a simple, convenient and inexpensive way to monitor the condition of the surface of the road, identify maintenance and rehabilitation needs, and ensure that road maintenance budgets are spent wisely. It is a statistical measure and requires manual survey of the pavement. And as I told you, there are two documents. One is IRC SP83, other is ASTM code. IRC code does not give method of calculating PCI for rigid pavements. It adopts a distress rating system for repair and maintenance of concrete pavements. ASTM method is quite elaborate and comprehensive, and it gives a detailed procedure for getting the PCI from visual survey of the pavement. And my focus in this session is to elaborate ASTM D6433-07 method. ASTM divides the PCI into 7 classes as follows. Depending upon PCI range, the class varies from good to failed. But in practice, a PCI lower than 40 is almost impassable. IRC SP83 consider distress rating from 0 to 5. 0 means there is no distress, that is excellent, and 5 means very poor, which is unsafe to travel. And type of repair can be appropriately decided from this distress rating. According to ASTM, a PCI is developed based on visual inspection and observation. The first step is identify branches of the pavement with different usage like roadway, parking, urban or non-urban. Then divide each branch into sections based on pavement design, construction history and traffic. Each section is divided into sample units, and here each slab is a unit now. If the pavement slabs have joint spacing greater than 8 meters, subdivide each slab into imaginary slab of less than or equal to 8 meters in length, and the imaginary joint dividing the slab is taken in perfect position. The type and severity of pavement distress is assessed by visual inspection of the sample unit, and the quantity of the distress is measured and is used to calculate PCI for each sample unit. The PCI of the pavement section is determined based on the PCI of inspected sample unit within the section. There are 20 types of distresses which are considered as per ASTM procedure, and these are almost same in both IRC and ASTM. These distresses include riding quality, blow up or buckling, corner break, divided slab, durability cracking, faulting, joint seal damage, lane shoulder drop off, linear cracking, patching large, patching small, polished aggregates, pop out, pumping, punch out, railroad crossing, scaling and map cracking, shrinkage cracks, spalling, corner, spalling joint. IRC SP83 suggests use of bump integrator or network survey vehicle for roughness measurement. Moving profilograph or laser device are often used to measure depth of irregularities in the road surface. The roughness of a pavement is commonly reported in terms of unevenness index as measured by the bump integrator, and the condition of the road surface is assessed based on IRI value, that is International Road Roughness Index. So if it is less than 3 meters per kilometer, it is good. If it is more than 4, it is poor. ASTM standard says that riding quality must be evaluated in order to establish a severity level for blow up, buckling and railroad crossings. It means that riding quality as such is not a parameter in PCI calculations, but riding quality is a parameter to rate the blow up blow up, buckling, and railroad crossing into different severity levels. Three severity levels are defined in ASTM. One is low. When you have low vehicle vibrations, for example from corrugations, and they are noticeable but no reduction in speed is necessary for comfort or safety, or individual bumps or settlements or both cause the vehicle to bounce slightly but create little discomfort. That is low severity. Medium severity is when vehicle vibrations are significant and some reduction in speed is necessary for safety and comfort, or individual bumps or settlements cause the vehicle to bounce significantly, or both creating some discomfort. And high severity is when vehicle vibrations are so excessive that speed must be reduced considerably for safety and comfort, or individual bumps or settlements or both cause the vehicle to bounce excessively, creating substantial discomfort and a safety hazard. So that is how you measure the severity level for blow up and railroad crossings. Blow up or buckling. Blow-ups or buckles occur in hot weather, usually at a transverse crack or joint that is not wide enough to permit slab expansion. I have explained all these distresses in concrete pavement and their causes and repair in my two videos, and these are available on my channel. You must watch them to understand different types of distresses in a concrete pavement. As per IRC, as I told you, degree of severity is from 0 to 5, and depending upon the height difference between the slabs, that is, if it is less than 6 millimeter, it is severity level 1. If it is more than 25 millimeter, it is 4. And when the slab is completely shattered in 4 or more pieces, then it is 5. But in ASTM procedure, each distress is evaluated under three categories of severity, that is low, medium and high. And in the case of blow up, severity is measured in terms of riding quality. What it says that buckling or shattering causes low severity ride quality, and I defined what is low severity ride quality. Medium severity is when buckling or shattering causes medium severity ride quality, and high is when it is high severity ride quality. Now this is a low severity buckling or blow up of the slab, and this is a high severity or shattering which causes high severity in the riding quality. How to count? At a crack, a blow up is counted as being in one slab. However, if the blow up occurs at a joint and affects two slabs, the distress will be recorded as occurring in two slabs. When a blow up renders the pavement impassable, it should be repaired immediately. Distress number 3 is corner break. A corner break is a full depth crack that intersects the joint at a distance less than or equal to half the slab length on both sides. A corner break, as per IRC, if the width of the crack is less than 0.5 millimeter and it is only in one corner, then it is severity level 1. If it is more than 1.5 millimeter, that the width of the crack, and length of the crack is more than 6 meter, or 3 corners are broken, then it is severity 4. Or if 3 or 4 corners are broken, it is considered as degree of severity 5. Now in ASTM, low severity crack is when the width is less than 13 millimeter and crack of any width with satisfactory filler but no faulting, and the area between the break and the joint is not cracked or maybe lightly cracked. That is the definition of low severity corner break. In case of medium severity, crack is non-filled with width more than 13 millimeter and less than 50 millimeter. A non-filled crack less than 50 millimeter with faulting less than 10 millimeter is also considered medium severity, or any filled crack with faulting less than 10 millimeter. This is a medium severity corner crack. And in case of high severity crack, it is a non-filled crack more than 50 millimeter wide, or any filled or non-filled crack with faulting more than 10 millimeter. Now, since IRC SPT 83 categorizes the distresses for the purpose of maintenance of payment and not for the calculation of PCI, we shall now discuss the method as suggested in ASTM only. So the next distress is divided slab. As per ASTM, the slab is divided by cracks into 4 or more pieces due to overloading or inadequate support, or both. If all pieces or cracks are contained within a corner break, the distress is categorized as a severe corner break. Here, level of severity, low, medium and high are based on difference in elevation. If it is more than 3 mm and less than 10 mm, it is low. 10 to 20 mm, it is medium, and more than 20 mm, it is high. Then fifth is decracking or durability cracking. Now, durability crack is caused by freeze and thaw expansion of the large aggregate, which over time breaks down the concrete. And this type of distress may eventually lead to disintegration of the entire slab. Low severity here is when this crack covers less than 15% of the slab area. And medium is when the crack covers less than 15% of the area and most of the pieces are loose and or missing. Or the crack covers more than 15% of area. Most of the cracks are tight, but a few pieces may be loose and or missing. That is the definition of medium severity of a durability crack. And the high severity is when the crack covers more than 15% of the area and most of the pieces have come out or could be removed easily. Similarly, each type of distress is evaluated, and in this performa, you have 19 types of distresses because riding quality is not indicated here as it is the part of blow-up and railroad crossing. Let us say you examine 20 slabs, and these are the 20 slabs of a section. 1, 2, 3, 4, and this is the distress type. You prepared this kind of table here. Let us say distress type 22 with low severity, there are 3 slabs. So this is 1, this is 2 and this is 3. Only 3 slabs are with distress type 22, that is your corner break, and with low severity. Now because there are 20 slabs total, so density is 3 upon 20 into 15. Similarly for other 22, that is again corner break with medium severity, there is only 1, that is 22M. So you prepare this table indicating the distress type, severity level and number of slabs, and density is calculated as number of slab affected divided by total number of slabs into 100. Now this distress type 26, which is joint seal, is not rated by density. The severity of distress number 26 is determined by the sealant's overall condition for a particular sample unit. If it is low severity, deduct value is 2 points. If it is high severity, it is deduct value of 8 points. So again we come to the same table that here 26 is high severity. So you have 100% density and corresponding to that you have 8 deduct value. Now how these are calculated, I'll tell you. Now the deduct value is estimated based on these curves which are suggested in ASTM. Now that is the distress density percent and their deduct value. For example, for a corner break distress number 22, you have the low severity level here, low severity and 15% density. So that is the curve for low severity. Take 15% and corresponding to 15% you have something like 12.5. So you mention here 12.5. Similarly for blow up, that is distress number 21, you can calculate. You have a separate set of curves for low severity, medium severity, and high severity. Similarly, for all types of distresses, curves are presented, curves are given in ASTM standard to determine the deduct value. Once you get the deduct value for each distress, the next step is to calculate PCI. And the procedure for calculating PCI is like this, that for each unique combination of distress type and severity, add up the total number of slabs in which they occur. I told you that distress number 22 occurs in 3 slabs, so there are 3 slabs here. That is low severity, 3 slabs. So this is the 15% density. Then divide the number of slabs by the total number of slab in the sample unit and multiply by 100 to obtain the percent density, that is your 15%. For each severity combination, you have now density. Then third step is determine the deduct value for each distress type and severity level combination using corresponding deduct curves. I explained to you how this 12.6 value has come for low severity of distress number 22. Again, you can see here that for distress number 22, you have 15% as the density and corresponding to 15% you have 12.5. So you tabulate all these values here. Then next step is determine the maximum corrected deduct value. After preparing that table, now you find out what is the maximum corrected deduct value. And here the guideline is like this, that if none or only one indivisible deduct value is greater than 2, the total value is used in place of maximum CDV. CDV is corrected deduct value in determining the PCI. Otherwise, maximum CDV must be determined using the procedure as given below. And the procedure is like this. List the individual deduct values in descending order. And now here you have 8 values. So place them in descending order. 30.5, 25.1, 12.6 and so on 4.4. That is the highest value, that is the lowest value of deduct. Now determine the allowable number of deducts M using this equation. 1 plus 9 upon 98 into 100 minus HDV, that is the highest deduct value, and highest deduct value is 30.5, and M is the allowable number of deduct including fractions, and that must be less than or equal to 10. So in this case you find out what is M. M is 9 upon 98 into 100 minus highest value 30.4, that is 7.4. It means maximum deduct value can be 8, but because it is not completely 8, so you can say that the first 7 deduct value will be taken in full and the last value 4.4 will be 0.4 times, that is 0.4 times of 4.4, that comes 1.76. So now you have the deduct values like this. This 4.4 is replaced by 1.76. The next is that determine Q. Now Q is the number of deducts with a value greater than 2. Now in this case, this value is less than 2 and therefore while calculating or determining Q value, we ignore this value and so you have 1, 2, 3, 4, 5, 6, 7. So Q is 7 and total deduct values are now 100.5. Sum of all these values is the 100.5 and Q is 7. Now with these values, you find out what is maximum corrected deduct value and you use this graph. You use this calibration chart. That is for Q is equal to 1, 2, 3, 4, 6 and 9. Now in your case, you have 100 as a total deduct value and Q is 7. So interpolate between these two. So you get a value of 50. So corrected deduct value is 50 now. Now next step is reduce the smallest deduct value greater than 2 to 2 and repeat this procedure. What does it mean? That this 5.8 is now reduced to 2 and you carry out the same iteration again. So the total is now 96.5, 96.7 and Q becomes 6 because Q is taken only when this deduct value is more than 2. Again go to the chart, you get the corrected deduct value 49.5. Now carry out these iterations until the Q is 1. So you change each value to 2 and then find out what is CTV. Take the highest of these values. Maximum CTV is 51 and then PCI is calculated as 100 minus maximum CTV, that is 49. So for this section, rating is fair. Once you determine the unit PCI, then you can find out what is section PCI. And section PCI is taken as the area weighted PCI. PCI of section is summation of PCI I into AI upon summation of AI values, where AI is the area of random sample unit. So the sample unit which you have taken in this case, for example, 20 slabs you have taken. So what is the area of these 20 slabs multiplied by their PCI value, that is 40 which you obtained, and similarly you have another unit, so that is weighted sum of all these units is the PCI for section. So that is how PCI is calculated for concrete pavements as per ASTM standard procedure. Thank you very much for watching this video. If you have any questions, you can write in the comment box.